Briancox, the professor one, not the sweary one. And I just finished a series called Solar System. Can you guess what it's about? Well, scary, but everywhere's scary. Venus, though, it's so horrendous. So 90 times the atmospheric pressure here, so you'd be squashed into a little pancake and then you'd be dissolved by the sulfuric acid and toasted at 450 degrees. So it's not nice. So I don't believe in a God, right? However, I don't like the antagonism that occurs or is produced by this question. I mean, what you can say if you're a cosmologist, what you should say is, so we know that the universe was very hot and dense 13.8 billion years ago. We don't know how it got hot and dense. We don't even know, actually, if the universe had a beginning in time. Don't know. So that to me is where the science starts for me with I don't know.
Getting more to the point.
There is another way of thinking that says no, space-time is fundamental. Relativity is fundamental. So I'm saying that because there's debate. It's not. I think most physicists would say quantum mechanics is the underlying theory, some kind of quantum description of nature.
It's on a roll.
And out of that emerges.
It's on a roll. For how successful
quantum description of nature.
It's on a roll.
And out of that emerges.
It's on a roll for how successful it has been.
Yeah.
In accounting for everything.
Yeah.
Right. I mean, so why doubt it at this point?
Yeah. So maybe we don't know enough to start. So I think I'm not misrepresenting him. He would question whether you really need to have a quantum theory of gravity coming from quantum mechanics. I think he would question that. So the reason I'm saying that is to say it's an open question. We don't know.
So what about the fabric of space-time?
Ooh.
Is that emergent?
Well, so the recent work in the study of black holes, which is the tiny bit of research I still do. I had a PhD student and postdoc working on this. It's called emergent space-time.
What is that?
So it's the idea that space and time are not fundamental. So space-time is not fundamental. There's let's say a deeper description, which is basically a network of qubits to do the shorthand version. So qubits, quantum bits. So essentially it looks like a quantum computer. Absolutely not to say that we live in a simulation, right? No one's going.
He's a little defensive there. Have you noticed that? He sounded. I don't really mean that.
I don't know whether we live in a simulation. Nobody does, but I'm just saying it's not evidence for that.
Right.
Mm-hmm.
But it's beginning to look like you can say, well, let's say a notion of distance can emerge from a network, an underlying network, which doesn't have. I would be delighted if we found life elsewhere, because I feel it would take some of the pressure off. Because my fear, the thing that keeps me awake at night is that life is extremely rare in the universe, and complex life is so rare that we might be the only planet in the Milky Way galaxy where complex life exists currently. So that's a guess. It's a possibility. I cannot claim. I'm not saying it definitively because we don't know. So if that's the case, then it means if we this up, there might be nowhere else. So my response, if a flying saucer descended now over Broadcasting House here in London, would be one of relief. Be like, thank God that it's not only down to us now, because, we're not making a very good job of it.
That science doesn't rule out the existence of a creator.
No, but in the sense that I just said, that I think we're overstepping the mark. I do not believe there's any evidence for a creator. However, there certainly isn't the point is that the correct thing to say is we don't even know whether the universe had a beginning. I don't even know whether it was eternal. Nobody does. So that was the point I was making. The honest answer is, personally, I wouldn't go anywhere. I'd stay on Earth because it's all really horrible. So the surface of Mars you could stand there, you'd be okay. Mercury, you wouldn't. Venus, you definitely wouldn't. It's 450 degrees Celsius or so. Sulfuric acid rain. And actually one of the experiments we do in the series demonstrates, it's a chemistry experiment again, demonstrates what would happen to you if you skydived through the clouds of Venus. If we remove the problems away, I'd like to stand on the surface of Neptune's moon Triton. But it's this kind of frozen place with strange eruptions from the surface that kind of rise up into space but then go flat because of this tenuous atmosphere that the place has. So,
Kirsten, what do you think? It's an interesting question. Do you think there is some sort of creative being that exists beyond science?
I'm going to give you my favourite answer to give to any science question if I don't know. I don't know. I'm with you, Brian. We don't know. It's like Brian says, I'm going to say there's null evidence. Not no, not some, null.
There's a very quick, serious point.
it's just, I would love to stand there and look out onto, with Neptune rising in the sky over this frozen surface. I'd love to do that. But I'd put a big coat on and, and come back quickly. Size and scale of it. I mean, in the piece of the universe we can see, there are something like, roughly, 2 trillion galaxies. We haven't counted them all, but that's an estimate based on surveys of the local universe. 2 trillion, 2,000 billion galaxies. And each galaxy is, let's say, around the size of the Milky Way. Some are bigger, some are smaller, but the Milky Way has 400 billion stars in it. It takes light over 100,000 years to cross a galaxy. And there are 2 trillion of them in the piece of the universe we can see. And we're very sure that that piece that we can see is a small bit of what may be an infinite universe beyond. We don't know. I'm going to Triton. I need to get big coat. Great thing about this series, Solar System, is it's all based on new discoveries, new ideas, new data. So I learned a lot in making the series. I mean, we have discoveries, images that were taken in 2023. So it's all during filming. Something like, I can't remember the number, 40-something spacecraft currently active in the solar system, on the surface of Mars and actually out beyond the orbit of Pluto. And the idea of this series was to use the most up-to-date data, which is a great idea until you have to film the series because you're sat on a volcano, having been delivered there by helicopter. That's a cliche, but it's what people expect of me. And someone rings up from London and says, we've got a new, that thing you were going to say is not right because a paper got published yesterday. She said, we're going to go over this ridge. And I was with her in the cockpit and then the film crew are behind in this. And it's like Indiana Jones and the plane goes, wow, like that, and dropped. And I turn around and Julius, the director of photography, is back there. And I saw him and the camera's floating and he's going, like that, and the camera's doing that. And then he caught, because everything went weightless, and then he caught it again. We do in the series talk about Mars and Mars's moons, Phobos and Deimos. One of the things that I didn't know, one of the most surprising things that we talk about in the series, there's this possibility that the mountains of Venus are coated in essentially metallic snow, which is just a beautiful idea. So it shows you how the laws of chemistry that we see and experience and investigate here on Earth, they're universal, but you put them in different conditions and you get very different outcomes. There are conditions out in the solar system that we can't recreate even on laboratories here on Earth. Extremes of not only strange chemical composition but pressure and temperature that are very difficult or impossible to create here. So you can use the solar system just as a chemistry set. And there's a real sense of that throughout the series. In the atmospheres of gas giants.
Yeah, and I think a point, and as scientists, we need to be humble about the fact that we don't know everything. And we shouldn't pretend to know anything on a lot of questions because climate change is so incredibly complex. The marine system is all these different inputs and circulations and different drivers. And so, we get to the limit of our knowledge. And I think really what you're trying to say is we need to be careful not to go beyond what we know.
The great Richard Feynman, the great Nobel Prize winner, it's a beautiful quote where he says that he says, what is the meaning of it all? Right? And he says, in the end, we have to admit that we do not know. But in admitting that, we may have found the open channel. That's the key to science. We don't know.
Right, no one's going.
He's a little defensive there. Have you noticed that? He sounded. I don't really mean that.
I don't know whether we live in a simulation. Nobody does, but I'm just saying it's not evidence for that.
Right.
But it's beginning to look like you can say, well, let's say a notion of distance can emerge from a network, an underlying network, which doesn't have the notion of distance or geometry in it. So
you just described subspace from Star Trek.
Did I?
Kind of.
Possibly.
Yeah, it's like this underlying substrate where the laws of physics aren't necessarily in play, which is why you can go faster than the speed of light.
Well, information goes faster.